Welcome to LabMinutes.com. In this video, we will look at Dynamic Multi-Point VPN or DMVPN. For those of you who has been using an IPSec or GRE over IPSec to connect your remote sites point-to-point, you know it's pretty laborious and time-intensive to configure the tunnel interface every time you bring up a new remote spoke sites, and because that's required a new interface to be configured on the hub router. So if you have like 100 spoke sites, that means you need to configure 100 tunnel interfaces on the hub router, and not to mention the IP address that you need to assign to the point-to-point tunnel interface. For example, if you do a /30, and that you can burn through a lot of IPs. So what DMVPN allows you to do is to come up with one big non-broadcast multicast network, very similar to what Frame Relay was capable of running, so that all the hub and spokes can share a common subnet and talk directly among each other. Especially if you enable spoke-to-spoke tunnel capability, there's no reason for the traffic to traverse the hub anymore to reach the other spoke, as if well, compared to if you were to run the point-to-point IPsec, GRE over IPsec. So DMVPN heavily relies on a protocol known as NHRP. So if you're not familiar with that protocol, I definitely recommend you looking up our NHRP video on our website and go through the video and just make sure you understand the basic of the protocol, because in this video we'll basically assumes that you have a good understand the concept of the NHRP and just kind of concentrate on the add-on config, which is on the CryptoMap side of things, to bring up the DMVPN. So in our diagram here, although the physical topology we have 5 routers, we're just going to use 3 in this particular lab. So R4, R1, and R5. And R1 is going to be acting as a hub, where R4 and R5 going to be our spokes. So let's get started on the configuration. I already have the configuration for the hub and spoke kind of templated out already, just to speed up our configuration. And again, this is a config that we used back in our NHRP videos. But let's step through that real quick. So we have a tunnel for the hub, tunnel interface, tunnel 1, and the IP address 1.1. We have the network ID 1, hold timer, registration timeout. We would not need that at this time. Tunnel key, so all the basic configuration, and enable NHRP in the hub. So let's start with router 1. Just copy and paste all those in. And on the spoke side, we have R4. I don't need that. And provide static mapping of the hub tunnel interface, the physical interface, and then give it the IP of the next hop server. Let's modify that for R5, so that would be 1.5, 1.5, and then 55. So here you can see, just to bring up a second spoke site, you can just reuse the previous spoke template, and you don't even need to touch the hub router configuration. Okay, here on the hub side is learning the 2 spoke subnets, 44 and 45, and of course it has 2 EIGRP neighbor. Okay, so here we have verified that our NHRP is configured correctly and it's all working. And we can also try to do a ping 16.55.1, sourcing loopback 0, and we can ping no problem. Okay. So now that we know that an NHRP is working, we can move on to our IPsec part of the configuration. So let's do that. Actually, before I move on, let me show you Wireshark Capture. And here we're looking at R4 Fast00 interface, which is the source interface for the tunnel. You can see everything comes up in clear text, so you can see everything. Okay, and NHRP registration, request, and reply. So all's good. Okay, now on R1 we're going to start our IPsec configuration first. If you're not familiar with IPsec configuration, first we do phase 1 configuration, which is crypto ISCAMP policy. So create the related policy. Here you have different options. Start with authentication. Just going to do pre-share key. Encryption, we're going to go with AES with high security 256 group. We can do, you can see there's various groups you can use. Here we'll just use group 2. Then lifetime, just going to pick X86400. Okay. Next, we create or we define the ISACAMP key. Call it Cisco. And with the address, so here's the one of the difference that on the DMVPN as opposed to the other regular point-to-point IPsec. So one nice thing about DMVPN is you do not need to know which IP the spoke will be coming from. So if the spoke has the dynamic public IPs, for example, there's no way for you to configure that IP on the hub side. So on the hub side with the DMVPN, it actually allows the spoke to be coming in over any IP, because spoke is usually the one that's initiate the IPsec connection. So here, but of course, I mean, if you want to put additional security and all your spoke sites have the static public IP, then you can obviously list all the list of spoke IPs here. But here we're going to do just any IP that's coming in. Crypto ISACAMP, just going to turn on keep alive real quick, do a 10.3. Okay, now we're going to configure IPsec transform set for our phase 2. So we're going to call it ESP AES256 and SHA. So ESP AES 256 and then ESP SHA. Just going to do HMAC for now. So depending on what version of code you're running, you might not see all these options. I think these are fairly recent. They made available or are available on the newer iOS version. So under transform set, you can do mode, either tunnel or transport. So if you don't know the difference between the tunnel and transport, basically the transport allows the header of the GRE header to be, or actually the header of the ESP to be the same as the GRE. So the router itself will eliminate one of the header and save yourself 20 bytes. So if you look at the header on the packet, you will not see the additional IP header. But that's only applicable if the termination of the GRE, termination point for the GRE tunnel and the IPsec is the same. So that means the sourced IP and destination IP for those are the same, which is what we are doing right now. So our physical fast Ethernet 00 on each of these routers are a termination point for both IPsec and GRE. So here we can do a transport, mode transport, and we can basically save ourselves 20 bytes of IP header. Otherwise, you have to use the mode tunnel, which is the default. Okay, here we do, next we do crypto, IPsec, and we have to give it a profile, and we call it DMVPN. Under here, usually you do set. If you were to do like a point-to-point IPsec, then you need to define the, let's see, transform set. Actually, we can just go ahead and do set transform set, and then copy whatever we had earlier. You can see you can tie this to a separate ISOCAM profile, which is not being used in our lab here. And you can define security association and security policies. So here we're just going to do set transform set. That should be sufficient for what we're doing. And then finally, on the tunnel, we're going to activate the IPsec on the particular tunnel interface. So the tunnel protection, IPsec, profile, and we call it DMVPN. Okay, so you can see ISOCAM is on, and you start seeing log messages on the route complaining that it's receiving a packet that's not encrypted. So you can see receive packet, not an IPsec packet. So let's scrap our crypto map config, and we can just reuse that on the spoke routers, which is again a pretty nice thing about DMVPN. Okay, now we move to R4, and you can see NHRP went down already. So you just go ahead and copy. And if you were to do just the hub to spoke topology and there's no spoke to spoke tunnel creation, you can just define your hub IP here for security. But here, since we are going to be doing spoke to spoke tunnel creation, we kind of need to leave this open. And again, in real life, your spoke might have dynamic public IPs or variable IPs, so you would not be able to predefine those IPs in here. So we're just going to go ahead and copy the whole thing. You can see we're not changing anything at all. Let's copy that in R4. Give it a sec, and immediately the neighborship came back on R4. We're going to do the exact same thing in R5. Give it a second, and it also came back up. Okay, if you do show IP route NHRP in R5, is seeing routes that belongs to R4 coming across the tunnel 1. So we're back to where we were with the connectivity. That's trying to ping. And we can ping successfully. Okay, show IP NH. And we have two dynamic mappings of R4 and R5 and R1 on R4. Show crypto scam is A. You can see there's a IPsec tunnel is currently up and running between R1 and R4. Okay. Do IPsec XA. And there's NCAP and DCAP's packet. So we know that's working. Okay, so now let's bring our Wireshark back up and rerun that. Before we were able to see all the NHRP messages, but now with NHRP being encapsulated within the IPsec, all you can see is just protocol ESP, and they're not readable since everything is now being encrypted. And again, this is exactly what you want if you're running your DMVPN infrastructure across the untrusted network like internet, which is the main application for DMVPN. And here's what it looks like. Okay. Do trace one source, and right now it's going through the hub. So on the hub side, let's look what we have real quick. We have no split horizon turned off. Now we're going to have no IP next hop. Because you see here, show IP route EHRP, R4 is pointing to R1 to get to R5. So now we're going to tell R1 not to overwrite the next hop IPs with his own IP. So the route will, not 10. It's actually 1. There you go, no IP next hop self. You can see EHRP bounces briefly and show IP route EHRP. Now the IP that came across as the next hop is the actual spoke tunnel IP, which is 1.5. So here, let's clear our screen real quick. Just to show you what we have right now, it's just one tunnel built and a static mapping. So next, we're gonna trace. Let's see, there you go. So trace. We do once. We do twice, just to show you the differences. Okay, and go back and look at this camp SA. You can see there's the second tunnel built. And that's between 13 and 17, which is R4 and R5. Have a look at our NHRP, a dynamically resolve R5 physical address, which is 4.17, and that's how it was able to build a GRE and IPsec directly to R5. And here, the first time we did the trace route, it took an extra hop through R1. But the second time, once the spoke-to-spoke tunnel was built, it was able to send traffic directly to R5 without going through R1. And just a final verification, it's 13.1, that's R4, R1. And here's the IPsec SA1317, and we did 5 ping, so we can see there's 5 NCAP and 5 DCAP. Okay. So the spoke-to-spoke traffic no longer needs to traverse the hub, but be a little careful if you have a bigger environment. The number of spoke-to-spoke tunnel may get pretty large, and that might put a lot of load on the routers. So make sure you keep an eye on like a CPU, and but again, that's going to be for the environment that there's a lot of spoke-to-spoke traffic. Otherwise, it's just going to be spoke-to-hub. Or if you don't want to run into that risk of happening, you can just turn off the spoke-to-spoke capability. So personally, I like to create the NHRP configuration of that first, so you can verify if that part is working or not instead of doing both the NHRP part and the IPSec part together, because if thing doesn't work, it's going to be a little trickier to troubleshoot. But if you start off with NHRP and make sure those are all working, and then you put on the IPSec part of it and it stops working, then you know there's IPSec that's breaking it. So it's always a good idea to split the configuration into two parts. It's just a little easier for your troubleshooting. So that completes our video on DMVPN Phase 1.2. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.